Imagine a crowd at a football match, creating the classic wave by standing up and sitting down in sequence. What they're actually doing is demonstrating a perfect example of a transverse wave. A transverse wave is a wave in which particles of the medium move in a direction perpendicular to the direction that the wave moves. Suppose you take a rope and shake it up and down, you'll notice that the disturbances, or waves, travel from one end to the other. Yet, the actual fibers of the rope move up and down. That's a transverse wave in action. Now, transverse waves have some fascinating properties and characteristics. Understanding these can help us grasp a lot of natural phenomena and technology around us. One of the most fundamental characteristics of a transverse wave is its wavelength. This is the distance between two consecutive points in a wave that are in the same phase. Imagine two consecutive peaks or troughs in the wave. The distance between them is the wavelength. It's like measuring the distance between two consecutive crests of water waves on a beach. Another important property is the amplitude, which is the maximum displacement of the particles of the medium from their original positions. In simpler terms, it's how far the particles move up or down from their rest position. If you shake that rope more vigorously, you'll increase the amplitude of the wave. Period and frequency are two other significant characteristics. The period is the time taken for one complete cycle of vibration to pass a given point. Frequency, on the other hand, is the number of complete cycles of vibrations that pass a point in a unit time. If a wave has a high frequency, it means the particles of the medium are vibrating rapidly. The speed of a transverse wave is also noteworthy. It's the rate at which the wave travels through the medium. The speed depends on the medium through which the wave is traveling. For instance, sound travels faster in water than in air because water is denser. To summarize, transverse waves are waves in which particles of the medium move in a direction perpendicular to the direction of the wave. They have key properties such as wavelength, amplitude, period, frequency, and speed. These properties help us understand and predict how waves behave. Whether it's understanding the natural world, such as seismic waves during an earthquake, or technology like radio broadcasts, transverse waves are fundamental to our world. So next time you're at a football game and the crowd starts a wave, remember, you're not just participating in a fun activity, you're demonstrating the principles of a transverse wave. And when you shake a rope up and down,